So for this type of question, this is known as the type C question. We have our function x and our function g. So we're going to prove that the composite function gf exists. So we're going to prove gf. As you can see, the f is in g. So we're going to find what is our range for f. Okay, so in order to do that, the first thing is we're going to plot this into the calculator. So we're going to plot this in our calculator. We're going to put x minus 3, alright, a divide sign, and then after that we're going to put in our restriction. So when you plot this in the calculator in a GC, you get something like this. You have a straight line from here all the way up. So this will be 3 and this will be minus 3. And at this point will be negative 2, negative 5. Okay, so you can see very clearly that we have our range from here all the way to the top. So this will be our range of RF, which will give us negative 5 all the way to infinity. And then we have here for our domain of f, we will have negative 2 all the way to infinity. Alright, so once we get this done, the main thing that we want is our range of f. So we have our range of f to be here. So you can draw a number line. So when we draw the number line, we have negative 6 and negative 5. Why negative 6? Because you can see that our domain of dg is negative 6 or more, right? So I'm going to shade it because there's an equal sign below. It's going to be negative 6 or more, but our RF is from negative 5 all the way to infinity. So you can see that very clearly RF, and this is the domain of G. So RF is a subset of DG. So since RF is a subset of DG, so this shows that GF exists. The composite function of GF exists. Okay, moving on, we'll go on to part B of the question, the next part of the question. Usually they'll ask us to go and find the equation for our GF. So to do that, okay, I'm going to write it down here. So to find GF, we know that F is going to be in G, right? So we can write something like this. And then we can introduce the x. We're going to sub in x minus 3 inside of G. So we have x minus 3 square minus 4. And once you get that, open up the bracket, simplify it. We get x squared minus 6x plus 5. So this is not the answer yet. We have to find the domain of GF. So the domain of GF will be equal to the domain of f. And that will give us negative 2 to infinity. That's how important to sketch the graph for function f. So once we get this, we can clearly say that the equation for our GF will be this modulus of this, and the range, the domain will be x more than negative 2. So this is how we find the equation for the composite function GF. And the last thing to find is the range of GF. How do you gonna find the range of GF? I'm gonna show you here. So we're gonna plot this into the GC. For the equation of GF, we have mod x squared minus 6x plus 5. And then once you get this in the GC, you're gonna put a divide sign, open bracket, x more than or equal to negative 2, close the bracket. Press this in the calculator, you get something like this. You will be getting a curve, and then it go up and like this. But the main thing we want to find is the range of this. This is GF graph, right? So you can see very clearly it starts from here all the way up. So this means that, and it's touching the x-axis. So this means that the range of GF will be from 0 all the way up to infinity. So that's how you find the range of GF. Okay, for this type of question is the type D of function question. We have our function x given to us to be 1 over x cubed. So we're going to find what is f square x and so on, and then we're going to deduce the general equation, the general formula of f to the power n, and using that we're going to find what is f to the power 40. Now the thing is, for this type of question, it's more like we're going to substitute inside, keep substituting inside. So we're going to make the x 1 over x to the power 3 to be 1, not 1, x to the power negative 3. So it's much easier to see in this way. Now for f square x, what we're going to do, because of the square there, we're going to substitute one of the fx inside this x here. So we're going to substitute an x inside that. So I'm going to write it like this, equal, I'm going to put a bracket first, and you can see that in here it's supposed to be my x, but I'm going to substitute my fx inside here. So this will be 1 over x cubed. So I have substituted inside this bracket, and then I'm going to just simplify, open up the bracket. I'll be getting x to the power of 9, and where x is not equal to 0. So I'm going to keep doing this. Now for the next part, you can see that f cubed is just one step away from f square, right? So it means that I just substitute one more of function f inside the x to the power 9. So I will have a 9 here, and then I'm still going to put the same thing inside 1 over x cubed. So it's going to have this pattern, and when you manipulate this, you will get x to the power negative 27, where x is not equal to 0. And we continue for one more. You put the bracket negative 27, substituting the function f inside, manipulate this, you get x to the power 81, where x is not equal to 0. So from here we got to deduce what is the general equation. So from here you can see that x, we can see it from positive to negative to positive, so that means we have negative 1 to the power of n. This will help us to get the negative positive alternating, right? And then you can see that it's a power of 3. So 3n will be the next one. And this will get us the general equation, the general formula. Okay, so once we get that, it's easy to deduce what is f to the power of 40. We just have to substitute n as 40, where x is not equal to 0. And once you get this, press in the calculator, you get x to the power 340. Sorry, it's going to be like this. You can press in the calculator, it's going to get very big, but you can just leave your answer to be like x to the power 3 and 3 to the power 40, where x is not equal to 0. So this is how you do this question. So for our last type of function question, the type E question will be something like this. We have function f and function g given, but we want to find the value of the exact values of x for which these exist, right? For which fg, the composite function of fg is equal to the inverse of f. So we're going to find the equation for fg first. You can see that g is in f, so we're going to write like this. So we have f, and we substitute g inside. So this will mean that fg will be 3 minus 2 over x. Simplify this, you get 3 minus 4 over x. So this is the equation of fg. Now we're going to find the equation of f inverse. So do the same thing. We're going to let y equal to 3 minus 2x. And then we're going to flip everything, inverse everything, and then we're going to make y the subject. So making y the subject, this will be 3 minus x over 2. Okay, once you get this, you can write down the the domain if you want to. Now then we got to solve this thing by simultaneous equation. Yeah, so we're going to equate them together. So 3 minus 4 over x is equal to 3 minus x over 2. We're going to solve this 5x in the exact form because we want an exact value. So it's going to be plus minus 41 over 2. So there are two answers right there inside.